Luminol is a versatile chemical that exhibits chemiluminescence, with a striking blue glow, when mixed with an appropriate oxidizing agent. Luminol is a white to pale yellow crystalline solid that is soluble in most polar organic solvents but is insoluble in water. Luminol is used by forensic investigators to detect trace amounts of blood left at crime scenes, as it reacts with iron found in hemoglobin. It is used by biologists in cellular assays for the detection of copper, iron, and cyanides, as well as of specific proteins by Western blot. Luminol can be sprayed evenly across the area, and trace amounts of an activating oxidant will cause the luminol to emit a blue glow that can be seen in a darkened room. The glow lasts for about 30 seconds, but the effect can be documented by a long-exposure photograph. It is important that the spraying be evenly applied to avoid a biased impression, such as blood traces appearing to be more concentrated in areas that received more spray. The intensity of the glow does not indicate the original amount present but indicates only the distribution of trace amounts of substances left in the area. Synthesis: luminol may be synthesized by a reverse phosphorescence, two-step process. It begins from 3-nitrophthalic acid. First, hydrazine is heated with the 3-nitrophthalic acid in a high-boiling solvent such as triethylene glycol. An acyl substitution condensation reaction occurs, with loss of water, forming 3-nitrophthalhydrazide. Reduction of the nitro group to an amino group with sodium diphenate, via a transient hydroxylamine intermediate, produces luminol. Luminol was first synthesized in Germany in 1902, but the compound was not named luminol until 1934. Chemiluminescence. To exhibit its luminescence, the luminol must be activated with an oxidant. Usually, a solution containing hydrogen peroxide and hydroxide ions in water is used as the activator. In the presence of a catalyst such as an iron or periodate compound, the hydrogen peroxide is decomposed to form oxygen and water. 2H2O2O2 plus 2 hours 2O, H2O2 plus KiO4 or KiO3 plus O2 plus H2O. In a laboratory setting, the catalyst used is often potassium ferricyanide or potassium periodate. In the forensic detection of blood, the catalyst is the iron present in hemoglobin. Enzymes in a variety of biological systems may also catalyze the decomposition of hydrogen peroxide. When luminol reacts with the hydroxide ion, a dianion is formed. The oxygen produced from the hydrogen peroxide then reacts with the luminol dianion. The product of this reaction, an organic peroxide, is very unstable and is made by the loss of a nitrogen molecule, the change of electrons from excited state to ground state, and the emission of energy as a photon. This emission produces the blue glow. Used by crime scene investigators. History In 1928, the German chemist H.O. Albrecht found that blood, among other substances, enhanced the luminescence of luminol in an alkaline solution of hydrogen peroxide. In 1936, Carl Gley and Carl van Stiel confirmed this enhancement in the presence of hematin, a component of blood. In 1937, the German forensic scientist Walter Specht made extensive studies of luminol's application to the detection of blood at crime scenes. In 1939, San Francisco pathologists Frederick Prischer and A.M. Moody made 3 important observations about luminol. Although the test is presumptive, large areas of suspected material can be examined rapidly. Dried and decomposed blood gave a stronger and more lasting reaction than fresh blood. And if the luminescence disappears, it may be reproduced by the application of a fresh luminol hydrogen peroxide solution. Dried blood stains may thus be made luminescent repeatedly. Theory Luminol is used by crime scene investigators to locate traces of blood, even if it has been cleaned or removed. The investigator sprays a solution of luminol in the oxidant. The iron present in blood catalyzes the luminescence. The amount of catalyst necessary for the reaction to occur is very small relative to the amount of luminol, allowing the detection of even trace amounts of blood. The blue glow lasts for about 30 seconds. Detecting the glow requires a fairly dark room. Any glow detected may be documented by a long-exposure photograph. Drawbacks Luminol has some drawbacks that may limit its use in a crime scene investigation. Luminol chemiluminescence can also be triggered by a number of substances such as copper or copper-containing chemical compounds, and certain bleaches. And, as a result, if a crime scene is thoroughly cleaned with a bleach solution, residual cleaner will cause the entire crime scene to produce the typical blue glow, effectively camouflaging any organic evidence, such as blood. Horseradish sauce, via the enzyme horseradish peroxidase, catalyzes the oxidation of luminol, emitting light at 428 nanometers, which may result in a false positive. Luminol will also detect the small amounts of blood present in urine, and it can be distorted if animal blood is present in the room that is being tested. Luminol reacts with fecal matter, causing the same glow as if it were blood. Luminol's presence may prevent other tests from being performed on a piece of evidence. However, it has been shown that DNA can be successfully extracted from samples treated with luminol reagent. Excessive smoke in an enclosed space can result in positive results with luminol. For example, an excessive cigarette smoker who smokes in his or her vehicle. Related molecules: luminol, 5-amino 2,3-dihydro 1,4-thalase-indian. 3-amino hydrazide. 1,4-thalase-indian, 5-amino 2,3-dihydro. CAS, 521-31-3, C8H7N302 177.16, IABS IMAX 1347 nanometers and IMAX 2300 nanometers. EC, 7650 liters per molar, cm, IABS/IM, 355 413 nanometer, luminol, hemihydrate, 3-amino hydrazide NA salt. CAS, 206,658-90-4, C8H6N302 NA 1 2 hours 20 MW, 217.16, luminol, NA salt, 3-amino hydrazide NA salt. CAS, 20,666-12-0, C8H6N302 NA MW, 199.12, luminol, HCl, 3-amino hydrazide hydrochloride. CAS, 74,165-64-3, C8H7N302 HCl MW, 213.62, isoluminol, 4-amino hydrazide. CAS, 3682-14-1, C8H7N302 MW, 117.16, isoluminol, monohydrate, 4-amino hydrazide monohydrate, C8H7N302 H2OA MW, 195.15, isoluminol ABEI, 4-amino hydrazide monohydrate. CAS, 66,612-29-1. See also, fluorescein, diphenyl oxalate. References. External links: How Stuff Works, How Luminol Works, Luminol Demonstration in Turin.